In this video, I briefly want to look at a couple of exam-style questions that draw on the skills of expanding and factorising expressions and then write them as a multiple of a specific whole number. Here are the two questions. You might wish to pause the video and have a go yourself before continuing. There are some timestamps in the description if you wish to go directly to the answers. It is assumed that you have done some work on expressions and sequences. In the world of expressions, you'll come across the idea for a general rule for even numbers, which is 2n, where n is any positive integer or whole number. So when n is equal to 5, 2n is equal to 10, and if n is equal to 8, 2n is equal to 16. 2n is essentially the general rule for the 2 times table, and is therefore the general rule for even numbers. If we had 3n, this is the general rule for the 3 times table, where 3n is a multiple of 3. So if n is equal to 6, we have 3 multiplied by 6, which is equal to 18. And if n is equal to 12, we have 3 multiplied by 12, which is equal to 36. And we can carry on creating general rules for other multiplication tables. So 4n represents multiples of 4, or the 4 times table. 5n represents multiples of 5, which is the 5 times table, and so on. So you may be required to show that an expression is a multiple of something. For example, if we have 6n add 3 and you wish to show this as being a multiple of 3, we need to write this expression in the form of 3 multiplied by something. So we need to factorise the expression, and to do this, the terms in the expression must be divisible by 3. We can see that 3 goes into both 6n and 3. So we can rewrite this expression as 3, open bracket, 2n add 1, close bracket. We have ended up with 3 multiplied by something. That something being 2n add 1. So 6n add 3 is a multiple of 3. If, for example, we needed to show that 24n add 36 is a multiple of 4, then we need to factorise this expression and write it in the form of 4 multiplied by something. Both terms, that's 24n and 36, are divisible by 4. So we can factorise this expression, and we end up with 4 multiplied by, open bracket, 6n add 9, close brackets. Notice that in this example, we could have factorised the expression further, as 3 is both common to 6n and 9. So we could have ended up with 12, open brackets, 2n add 3, close brackets. But that's not what we're trying to do here. In this case, we just want to show that the expression is a multiple of 4. So all we need to do is end up with 4 multiplied by something. But of course it can be argued that 12 is a multiple of 4, so writing it as 12 multiplied by something isn't incorrect. Let's look at those 2 exam questions I showed at the beginning of the video. Here's the first question. The diagram shows a rectangular garden measuring 5x subtract 3 by 2x add 1 metres. The owner wishes to build a fence around the perimeter of the garden, allowing a 2-metre gap along one edge to get in and out. Here's the drawing. And question A asks, show that the fencing in p metres is given by the formula p equals 14x subtract 6. And question B asks, show that p is always an even number when x is a whole number. So let's look at the first question. To find the perimeter, we need 2 lots of this length, and we need 2 lots of this length. We then need to subtract this length of 2 metres. So p is equal to 5 subtract 3, add 5 subtract 3, add 2x add 1, add 2x add 1, subtract 2. Well, we've got the 5x here, and we add another 5x here, which is 10x. And then we've got another 2x here, and a 2x here, so that gives us our 14x. Now let's look at the constants. We've got a minus 3 here and a minus 3 here, which is minus 6. And then we have 1 here, add 1 here, so that takes us to minus 4. And then we subtract 2 here, so we end up with 14x subtract 6. So that's part A. Now we need to show that p is even. Well, we can do this by writing p as 2 multiplied by something. We can see that both terms, 14x and 6, are divisible by 2. So we can easily write p as 2 open brackets 7x subtract 3 close brackets, which is 2 multiplied by 7x subtract 3. And I'm just going to write in words that p is a multiple of 2, therefore p must be even. Now let's look at the other question. Expand x add 1 multiplied by x, subtract 1 multiplied by x add 4. Well, let's multiply out the first two brackets, which is x add 1, x subtract 1. Now I will do this the long way, even though it's the difference of two squares, which is x squared subtract 1. But let's just expand this out so you can see what I'm doing. We have x multiplied by x, which is equal to x squared. Then we have x multiplied by minus 1, which is minus x. Then we have 1 multiplied by x, which is plus x. And then we have plus 1 multiplied by minus 1, which is minus 1. And of course that simplifies to x squared subtract 1, the difference of two squares. So we now have x squared subtract 1 multiplied by x add 4. So if we multiply this out, we have x cubed add x squared multiplied by 4, which is 4x squared, subtract x, subtract 4. For part B, we have this long calculation of one expression subtract another expression. Notice that the second expression is the one that we had just simplified or expanded in part A. And we need to show that this expression is a multiple of 4. So what we need to do is to expand this expression completely, and then once it's expanded, we need to end up with 4 multiplied by something. So let's focus on the x multiplied by x add 3 multiplied by x add 1, and let's expand that out. Beginning with x multiplied by x add 3, well, that simplifies to x squared add 3x. We now need to multiply this with x add 1. So we have x squared multiplied by x, which is equal to x cubed, x squared multiplied by 1, which is x squared. Then we have 3x multiplied by x, which is equal to 3x squared. And then we have 3x multiplied by 1, which is 3x. And this simplifies to x cubed add 4x squared add 3x. Now let's simplify the whole thing, substituting in our simplified expressions. So we're going to rewrite this as x cubed add 4x squared add 3x, subtract, and I'll write this in brackets, x cubed add 4x squared subtract x subtract 4, close brackets. And this of course is the expression up here. Expanding out the bracket, we have x cubed add 4x squared add 3x subtract x cubed subtract 4x squared. We then have plus x, because a minus and a minus is a plus, and we have plus 4, because minus and a minus is a plus. We can see that we have an x cubed here and minus x cubed here, so they cancel out. We have plus 4x squared here and minus 4x squared here, so they cancel out. We have 3x, add x here, so that's 4x, and then we have 4. So we end up with 4x add 4. As we need to show that this expression is a multiple of 4, we need to end up with 4 multiplied by something. We can see that for both the terms 4x and 4, they are both divisible by 4. So we can rewrite this expression as 4, open brackets, x add 1, close brackets. So that's all I want to cover in this lesson. I have covered other algebra topics. I've also done a series of videos on number work, which you can also check out on the channel. So thank you for watching, and I'll see you in the next video.